Okay, there we go. Awesome. So we're going to go ahead and go into catalogs, Iceberg, and Delta, building the foundation for Lakehouse analytics. So first things first about me, as you can tell by my accent, I'm from America. I'm from Denver, Colorado, in the center of the US. We're known for our beautiful mountains and our skiing. I'm a developer advocate at a company called ClickHouse, which hopefully you guys saw within the description of this talk, which is a OLAP database, which we'll get into a little bit. I've been working in the database space for over 6 years. I mostly work with what you would quote unquote call new databases, basically NoSQL or OLAP, or just databases that have been built roughly in the last 10 years or so. And I love open source because I think it's very collaborative and powerful in helping people not only work together more, but also work together to solve a common goal. In a way, open source is a very special thing, especially in the technology sector. It's not common across all of them. So today we're going to talk about 4 things mostly, and then we'll also have a small, I guess you could say, AI section at the end. Don't worry, I swear it has to do with the topic. It's not just randomly inserted here. So we're going to do the history of data warehousing, what are data lakes, what are analytical databases, and then combining them together. So really quick, the history of data warehousing. So about 30-ish or so years ago, we have what we call the traditional on-prem data warehouse. This is kind of funny in the fact that almost everything was on-prem in theory 30 years ago because we didn't really have cloud providers just yet. And also when we say on-prem data warehousing, even that's a very fuzzy interpretation in the fact that also back then everyone was just like database. It's a place that the data is stored. We didn't really have the discernment yet between data warehousing and databases, and even that can get, I think, fuzzy sometimes, even in modern conversation. 10 years ago, roughly, we finally started to shift our workloads to the cloud. This is when things like Snowflake or Databricks or Redshift or BigQuery really became available. Obviously, Redshift and BigQuery are very specific to their cloud providers, but just in general, we had more options for storing data. And this is also coinciding about 10 years ago when even the database space became very large. Like we went from like 5 database options to like 500. And at this point, we're probably staring down the barrel of like 5,000. So this is a really big deal about one particular way, which is that these companies, not just the cloud providers, but also companies like Snowflake and Databricks, had to convince people that it was safe to put their data warehouses on the cloud. Because the thing is, everyone was kind of ish okay with putting their customers' data on the cloud, mostly because it meant they could serve their customers continuously across, the world, basically. Like the cloud allowed you to set up, infrastructure in a different country, in a different place that you weren't necessarily in. But data warehousing normally at this point became defined as your internal business data, which in a way is very, very, you want it to be secure. It might be your secret sauce. It's, yes, normally customers' data, but more important customer data, like maybe you're holding, like in the US, social security numbers or other very sensitive stuff. And convincing people to put this on the cloud was not easy, and we have a lot to thank for these companies and these original pioneers, basically, because this also helped a lot of people in that it exposed this data to many more stakeholders internally. It used to be, it's a funny thing that I talk about, but we don't really have database administrators as much anymore. Literally, it's a statistic that the role is disappearing. It doesn't show up as much anymore, and that's partially because nowadays the people who have access to databases or data in general is expanding quite largely. Anybody in this room who's ever dealt with, many different teams within their company will know that everybody wants access to everything, and this was the start of making that possible, making it easier for people to integrate and just in general have access to this data instead of going through like one guy who was the only like key person who could do anything, just like the Jurassic Park movie. We don't want just one guy to run everything. If that's anything that we learned from that movie, that was the real takeaway for me, at least. Don't leave it all with one guy. And basically, one issue though is that this became eventually a little bit prohibitively costly. Like, unfortunately, it was one of those things where you were kind of vendor locked in, and there was a feeling that people were not, they weren't innovating as much because they had you locked in a box and you couldn't escape. But that's not really happening anymore because we now have a lot more what I would call open source alternatives for data warehousing and for, in general, real-time apps. And now we have our open data lake formats. So let's kind of take a look at that. So this is just another way to look at this basically when it comes to data warehousing, which is that you have something like an open data lake format under the hood. You have your Iceberg, your Delta Lake, your catalogs, etc., which you can kind of swap and replace as you desire. I shouldn't say replace as you desire because it's not like this is an easy thing to change, but you get to make the option. You get to make the choice, and then you have all kinds of interactive apps and analytical databases and other such sitting on top. And this is kind of what this really evolved into. I took this off of someone's blog who kind of wrote a little bit more about the promises that we were promised with Lakehouse 1.0 versus 2.0, which is that basically 1.0 is describing the old ways, which is that you would be locked in on your data format. It would be tied to specific vendors. It would be very proprietary, and it was not that great, to be honest, as you can see by this little lock icon over here on the left-hand side. But now we have 2.0. We have many different types of, you can use any kind of cloud storage. This has become irrelevant at this point. It used to be more contentious as to which cloud storage you would be allowed to use within your data lake, but now it doesn't matter. They all accept them all. The data lakes now have become mostly Apache Iceberg and Delta Lake, but also Apache Hudi as well. And now you can use whatever you want on the front end for the compute engine in particular. And that's really great and powerful because it allows internal teams to also use what tooling they prefer, which is a very powerful thing because not everybody is going to agree on the same tooling. As anyone who's ever worked with engineers should know, we don't all agree. And this allows a little bit more leverage in the fact that people can kind of use what they want and all the data is stored in one place that they can pull from, basically query back out of. So this is also a really good information. This is from our design team. I did not steal this from the web. But this is basically a really good way to kind of show what a data warehouse really is for a typical data stack for a data warehouse. And this also defines now what, a DB is in this space, which is that a DB is, a specialized database that then feeds into your data warehouse. This is also how, if you've ever heard the term data swamp, kind of how it comes into play, which is that you just have so much data. It's practically it's swampy, it's hard to shift through, it's hard to get through it. But this is normally how it looks like, which is that you have a lot of sources on the left-hand side here that you see. You have your apps, your servers, your raw files, your data stores, which obviously just go straight to your DBs. You have streaming layers, you've got some batching layers. Once you get into the actual data lake, you've got your object storage, maybe a file system if that's what you're using, and of course data movement and transformation before it eventually makes it into your data warehouse. And then that powers things like real-time analytics, the obvious business intelligence use case, and nowadays a lot more machine learning and Gen AI. I'm noticing the data science is in here, but really that's been used for a much longer period anyways. And then observability also kind of plays a role here. We don't think about it that way. We normally do think about observability not living in your data warehouse, but that's actually not really coming into play as much, we're finding. A lot of people are wanting to integrate this observability data into their data warehouse, and we've seen people put it in there as well. But yeah, this is kind of like the average stack and the average data tools. And just a note here, don't think that I'm being favoritism here on the tooling on here. This is just some of the big ones that people should know about. And so this basically starts to look like this. So you've got your object storage, which I've already said is basically irrelevant. Just use whatever you want. Use whichever, relative cloud provider that you have, or if it's a file system on your computer, that also works, I suppose. But the goal is to basically have many different query engines that can connect to a catalog and query that underlying format. So the catalog, as a friend described it, is like a phone book for discovering governance, what is in the tables, and who has access to them. So that's basically how the catalog fits in here. And then the query engine itself on top can be tooling like Apache Spark. It can be Snowflake, which is a very obvious one. It can be things like ClickHouse, which is obviously a real-time database. But basically, all of these have their place. And many people use all of the 5 above. Funny enough, they use many different query engines, again, depending on the team, and that's what this allows. I will say this, most people don't mix and match catalogs as much. They normally stick to one, but again, it could just be that somebody knows one catalog better. And some of these catalogs are also, I will say, not interoperable with every single data lake. Most of them are in various ways, but some of them are, more specific to Iceberg or more specific to Delta Lake. But for the most part, they all kind of work. And so we also asked ChatGPT, what are the open data lake formats and their engine compatibility? and also kind of who's the creator and steward of this. So you have three major ones technically, though Apache Hudi has kind of been losing its steam, just mostly because a lot of the people who supported it went to Apache Iceberg when that became open source and available. So you have Delta Lake, which is obviously taken care of by Databricks. You have things like Spark, Presto, Trino, and Snowflake, who at least can read from it and who could take advantage of it. And then you have things like Apache Iceberg, which was originally created in Netflix, who then gifted it to the Apache ecosystem, and so now it's got engine compatibility with very similar list, except for ClickHouse and Dremio would be here because we have a little bit more, I guess you could say, quote unquote, favoritism towards Apache Iceberg. And again, these are just like the major engines. There are hundreds of options for this that you can use, but these are the big ones. And I read a funny blog when I was originally writing out some of this information about like the differences between Apache and Delta Lake, and they were like, this is an expert person who gets asked quite often, like, what should I use in my business? And they described it as frying a fish. They were like, you can fry a fish in oil, you can fry it in butter, you can fry it outside, you can fry it inside, but in the end, you will end up with a fried fish. They were like, that is basically what these two are. They're both powerful, they're both supported by extremely large companies who have a vested interest in making sure they stay powerful and great, and they're both used worldwide. There's no like, oh, in Australia we only use Databricks, and in the US we only use Apache Iceberg. No. All over the space, they're both great, and we're really happy that they both exist because we don't like monopolies. Monopolies are not super great. This causes them both to become obviously very intrinsically good at competing somewhat with each other, but also that means that they get better. So we all win in the end. We win as they get better, but this is just some of the like features that they offer and some of the things that they both have versus some of them do not have. And do remember that, you know, almost every single feature comes with what I would say is a downside sometimes. So just because Delta Lake doesn't offer all of these features doesn't mean that's a bad thing. There's probably a very good decision for some of them, or why they're partially in there, but they'll be coming soon with new features. And yeah, so as you could see, they have a lot of very similar, I would say over half of these are very similar features, and these are just the top ones. There's also many other little features that they can compete against each other on. And normally where it really comes down to when people decide to use them is they already were using Snowflake or Databricks, or the person who's making this decision has like a really strong viewpoint or has a history with one of the technologies, so they're going to go with what they're comfortable with, which is totally fine. Though I will admit, I feel like a lot of greenfield projects also just end up on Apache Iceberg personally. But again, that's not saying to say that it's the best. It's just that they are different. This is also talking about how ClickHouse has started to really invest ourselves into making sure that we can support all these features on Iceberg. So like I said before, all those query engines, all those DBs that can hook up to this data lake format, you have to be able to take advantage of these features. Like the pruning, and especially the partition pruning, is important for the speed. This is kind of what makes Iceberg a better, data format, basically. It's to allow you to take advantage and also to be able to take advantage of all the catalogs that are available as well. And we did the same thing with Delta Lake because we're not a particular, we're not going to be like only one. We believe in both. And again, we believe they're both going to keep getting bigger and stronger. And so really quick, I want to kind of mention what analytical databases are. And I kind of want to show a quick demo here to kind of highlight. So when we talk about data-driven applications, which this is just a demo page that ClickHouse has to kind of show off what we talk about. So this is analytics for PyPy packages, and this is real time. This is just me pulling it up on the internet here in the conference. I didn't preload this or anything, obviously, but basically I can click on anything here. I can click on a repo. And all of this data is being stored within ClickHouse. And what makes it real time is, as you noticed, I just pretty much clicked on it and it loaded instantly. That is real time. That is a user-facing analytics that needs to load quickly. That's pretty much the straight up definition. If you ever interact with any kind of website that maybe doesn't display graphs, but displays information to you very quickly that is maybe analytic in nature, you're most likely being served by some kind of analytical database under the hood. Might not be ClickHouse, but it's probably something like it. And especially if you can do something like this, where you interact and everything updates very, very fast and quickly, this becomes really important. Because real time is, like I just said, it's meant to be real time. You're meant to be able to interact with it quickly and get answers back very quick. Apparently this one is very popular in the US. That's fine. But basically, this is a really good example. This is also obviously meant to just show off how quick ClickHouse is because it's storing billions of rows as it queries this stuff out. I don't know what the heck that is. Let's see. That is a huge spike over the course of, I think, like a week or something. Yeah, it's like literally 3 days. I don't know, maybe it went viral somewhere for 3 days and got all of its people. Yeah, that's also really funny. But yeah, basically, this is just a nice little demo application to kind of highlight what we mean when we talk about real-time data-driven applications. Let me go ahead forward. Oh, this is a video just in case the internet didn't work. And this is kind of where we sit in this space when it comes to things like ad hoc versus and periodic workflows. Those are things like basic data discovery, generating reports. Basically, it can take a little bit longer and you only use it when you need it. You don't use it all the time. Apache Spark, for example, tends to fall in this category. And then you have what we call highly concurrent and interactive. So this is like you've got immersive data-driven apps. You're doing monitoring, alerting, detections, dashboarding, etc. That's where places like ClickHouse, Elasticsearch, and in particular Druid live. And then obviously you have things like PostgreSQL, MongoDB, and MySQL who can kind of be in this space. Like obviously you interact a lot. You query your SQL database probably all the time, but you might not be expecting it to be as real-time analytics focused. It's more about just like loading up a website and making sure the information is displayed properly. And then obviously the data lakes live somewhere in between basically these two. And yeah, so I really quick just wanted to mention that we have quite a lot of momentum, very popular, open source obviously, so you're welcome to take a look at it. And then you have many different deployment options as well. These are mostly the ClickHouse local ones. So this is just you running it locally on your laptop. But let's go ahead and get in now to combining some data lakes and analytical databases. So for one thing to note here, which is one of ClickHouse's, strong suits here, is the fact that we have support for things like materialized views, which I'm going to get into as to how they're useful for this. We have specialized data types, which are specifically useful when you're querying out of the Iceberg catalog, which also sometimes has specific data types. High insert throughput. We can be completely self-contained, which I'm going to link a user story that took advantage of that. And of course, the unmatched query performance. So basically what that means is that when our customers build something with us, when it comes to data warehousing use cases, it looks a little bit like this, where we integrate with things like their other databases, their streaming, obviously the data lake itself, your Delta Lake and Iceberg, and then your cloud provider, and whether that be, and again, that could be something like Snowflake and Databricks, we can hook up directly to it. Basically, we're like a nice technology that can either run alongside this or run on top. And when I say run on top, I mean it looks something, here, let me skip this slide. It looks something like this. So basically, this is what I say when we're running on top of it, which is that we basically both ingest data. We're both getting similar data sources. For the data lake here, you can imagine this as a pure data lake, like a pure like Iceberg format, just sitting in like an S3 bucket with a catalog in between here. Or you can imagine it something like Snowflake. That's what a lot of our customers do if they're running Snowflakes or Databricks and they want to have real-time access to some of their data. They'll use us and basically use us as a hot query or a hot storage. And then the data lake or their data warehouse becomes the cold storage. But basically, the way that this is working here is because we have faster insert rates, you don't have to wait for the data to become available. It can become available in milliseconds. Pretty much the second it's ingested, it's ready to come back out. Versus normally for a data lake or a data warehouse, you're going to wait a little bit longer. It doesn't normally take too long, but one person the other day told me they were waiting like 3 hours for their data, which seems a little crazy, but that's fine. But basically, with something like this, you would have ClickHouse sitting on top. You would be duplicating your data, but you would be removing it from ClickHouse after a certain point when the real-time analytics is less relevant, I guess you could say. For some people, that might be like a day, 30 days, 3 months. It just depends on, what you're querying back out. If you were, for example, somebody like Cloudflare who needs to give people visualizations for their applications, like observability information, I'm sure you would probably drop your data after like 7 days or something, the most recent data for that observability workload. And what's really important here is the materialized views. So materialized views is basically a query that runs on a timer. And what it normally is it's like, here, let me put up an example here. So you have something on your website that describes like how much bandwidth you're using right now. And this needs to be analyzed on the fly. But you can get the answer, but this is like the amount of bandwidth you've used for the past month or something like that. Like maybe it's like your electrical bill. That's actually a better way to put this in. Yeah, it's like the power usage you've had for the past month, all of that you've used. You need to get that query, but you want it to be really fast. You want this to load instantly pretty much for this person. So what you do is you add a materialized view that basically queries the data lake for their information, maybe like once a day, once a week, whatever is relevant for this. For this one, it's probably like once a day. And what what it will do is it will see if there's any new or manipulated or changed information in the data lake. So that's specifically where you would make updates and changes. Maybe for some reason you read the meter wrong, you put in the wrong number, you need to go ahead and update it, you change it in the data lake, and the materialized view will go ahead and query for this old data, quote unquote, the data that's not being stored in ClickHouse, and it will run that materialized view as often as you need to, and then you can go ahead and put the answer in ClickHouse. So that answer, that query, that data manipulation, if you want to call it that, will live within ClickHouse. And then obviously extrapolate this use case out to hundreds of questions or thousands. And these materialized views can just run when they need to, so you're not hitting the data lake constantly. Like basically every single time this question is asked, it will not go and fetch this question brand new. It will already have it preloaded and ready to go for you. And that's really important because if it had to query it every single time, you might not be getting to be taking advantage of, like I said, the very fast insert rates or even the fast compute, because if it has to go to the data lake, you might be getting latency from that question, from those queries. So it's really important to be able to take advantage of materialized views so you can do this ahead of time and have it pre-done. You don't have to wait. You can take advantage, well, not take advantage, but you can know the amount of latency you're going to be dealing with and just deal with it head on, basically. And this one is a very similar one. The only difference here is that they put all of the data in the data lake. This is great for people who, they don't need they're okay with the slower insert rate, basically. Like they don't need it as fresh. And then they can just do the data load, which is very similar. They're just reading and syncing the data periodically. With this one, it's actually normally a straight up duplication of the data though. So they put it first in the data lake, then they read it and sync it, and then they've got the data that they need with the answers, et cetera, within their real-time analytical database. And although I'm saying ClickHouse, this can work with things like Druid, Elastic. A lot of real-time DBs have this capabilities. Though I can't promise materialized views in all of them, but I know a lot of them have something like this. And then obviously this one's just basically the advanced version, which is you just add the MVs for faster queries here. That's really the only difference here. It's just the difference of still taking advantage of those MVs. So basically this is an evolution like a Pokemon. This is the beginning and this is the evolved. And then this is kind of like what this looks like in a nicer little visualization format, I guess you could say here, which is that you have lots of different writers. Some of them write directly to ClickHouse, some write to both, some write just to your data lakes, and then you have your catalogs. You could technically read straight to a data lake, like you could just read from ClickHouse to Iceberg, but normally most people are going to use a catalog. Like I said before, it's good for data governance and making sure the people who should be accessing it are, not just like random people. And then, but this one you'll note, the application is only querying ClickHouse. So everything real time, everything that's going to be the application basically asking a lot of questions will go straight to ClickHouse instead of going straight to the data lake, which makes sense, to be fair. I don't think there's that many applications who just query directly to a data lake. You would have, like I said, maybe ClickHouse, maybe a query engine, maybe something like Dremio or something else here, or Apache Spark that then feeds to an application. It would be a little strange to just go straight to it. So something I kind of wanted to talk about, which has become more and more relevant in the past couple of months in particular, especially the past year, which is the future of open data lakes powering AI agents. So this has become a very hot topic, and in general, everyone's kind of starting to, they're trying to, I guess, answer the call to this. Like people are wanting to build AI agents that take advantage of internal business data. So we did this ourselves, and I'll link to our story about it. I can't show our internal agent because it's got proprietary customer data, so not safe for putting out on the World Wide Web. But basically what we did is we built an internal data warehouse. It's built purely on ClickHouse with Iceberg being the underlying format for the data lake. But otherwise, the data is stored within ClickHouse. That's pretty much the pure storage for most of it. And from there, we are serving all of our customer data, the support tickets, the Salesforce data. I can't remember all the data sources, but we have like 20 or so going into it. And then our internal people can interact with it to ask questions. And part of this is to resolve the issue of having to ask an individual human some of these questions. As somebody might say, this removes like certain analytic roles from the company because the agent does it itself. It's running computations. It's getting the freshest data that it has. But just in general, this has been very powerful powerful for us internally, and we've had a lot of requests for other companies to be able to take advantage of this. But something I did want to highlight is the fact that, and I forgot to add it here in this deck, but if you look up here on the right-hand side, you'll kind of see what's an example of classic real-time analytics. And really what you're seeing here is just classic interaction with the database. You make a single query to a database, you say select from the table of human, give me data, and it sends you back insights. That's kind of how it works. It's kind of just what it does. You might have a middleware layer that might be like your front-end application who might manipulate this select query a little bit, make it have a little bit more detail, maybe have a token or something there for security. But basically, that's kind of the gist. But nowadays, when you're dealing with something like an agentic layer, the amount of queries is huge. Like, it's not endless, but it's a lot more than what you or I would do naturally. Like, again, even if we were looking for information that's stored within a database, we would normally start from the top and we kind of work our way down, or we'd have a longer select query, but it's still really only selecting from specific tables, or maybe you have to do multiple select queries and then run some kind of calculation yourself by hand. But basically, the agentic layer kind of does that itself. It just goes and hits the DB and asks for stuff and gets some results, and then it goes back. It's kind of similar to if you've ever interact with ChatGPT, it does something similar nowadays where you can kind of see in the top left where it's grabbing all the data from. So it's like, it'll hit Wikipedia, it'll hit like an event site, it'll hit some other stuff. Like if you ask ChatGPT about Øredev, for example, it will definitely hit like a bunch of websites, and you can kind of see it doing it up at the top. And that's basically what it's doing. It's querying out, I actually think it's querying technically a database, but the database is tagged with what is available, but it might also be real-time searching the web. But either way, basically, a lot of DBs are not built for this automatically. They were never built to get queried 100 times in a minute and be able to respond appropriately. But for ClickHouse, at least, this was not a problem. So what we went ahead and did is we now have an MCP server, which I'll kind of show what this looks like in a second. But we have an MCP server that hooks up with LibreChat, which we recently acquired this week. So LibreChat and ClickHouse will now be living together to quote unquote help agentic AI workloads along. And basically from there, internal users, for us as internal users, but also external people could work with LibreChat and MCP from ClickHouse. We have Amazon Bedrock and Anthropic API for just some extra I'm trying to think of the words here, sorry. Basically, to help with answering these questions. That's basically the agentic workload right there. And I kind of want to show what this looks like. So we have our real, so basically we took what we did with Dwayne, our internal data warehouse, and then we put it on the web for other people to interact with and take advantage of. So let me go ahead and show this demo. So this is Agent House. So Agent House basically has a lot of different data sets. Here, I'll go back actually to the top here. We'll go ahead and ask, what data sets do you have? And it has a bunch of public data sets that we've thrown into ClickHouse that powers it. Oh no, let's see. Oh, my credit balance is too low. Well, that's unfortunate. Well, this is why I keep stuff on this just in case. Live demos are always going to have something go wrong. You know, you can't be too lucky. So basically, the other day I asked this question to it. I said, "What data sets do you have?" And then it went ahead and it ran a list of databases. So it went ahead and ran a query where it asked for all the databases that are available within this ClickHouse instance. And you can see we have stuff for e-commerce and retail. We have some social media. What I normally take advantage of is the on-time transportation one because it talks about flight data. Then I asked it when was the best time to fly from Stockholm to Denver, of which it did a lot of queries, to come back to me and tell me that it only has US domestic flights, so I need to pick a different query. So then I asked, what about Denver to New York? And this is when it went back and ran some more queries. And as you can see, just by these little purple check marks here, as I said before, it's running a query. It's getting a response, it's running a query, it's getting a response, it's doing that automatically. And when I have enough API credits, it does this very quick. Like this was done in less than 5 seconds. Like in 5 seconds, it runs these queries and it just keeps running them until it gets everything that you want from it. And then it put up this very beautiful, it gave me a nice description down here as to when the nice time to fly was. And then it also does it up here where it gives you some code snippet as well as a preview. This is very nice so that I can visualize it myself. But basically, this is very similar to what Dwayne looks like internally. Obviously, the questions asked in the data set is our internal business logic, so that it's a little different, but it also has this nice visualization tool on the right-hand side. And yeah, the reason that we built Agent House was to kind of partially inspire people, but also some of our customers have taken advantage of this. And I'm going to see if I can get this to load. It wasn't loading the other day. Give me 1 second. It's like a cancer research one, but I don't know if I have it up. Let me see. Not ClickHouse. I probably need to go find it. But basically, one of our cancer research people recently worked on this. Let's see. It's going to give me weird stuff. Yeah. I'll just have to come back to it, unfortunately. But at least we have ours. But yeah, basically some of our customers have started to do this, and some of theirs are available for outside users to take advantage. Obviously, most of them are for internal. Again, this is normally used for business-facing logic, not so much for outside-facing logic. And that's very relevant nowadays for, for people who are building data warehousing. This is kind of the next, we say, iteration or step, is to be able to allow people to interact with an agent internally for their own company and be able to basically cut out the middleman in a way, which is kind of us. Basically, this data will become more transparent, more people will be able to access it, and more people will be able to interact with it. So if there's any relative takeaways, I guess you could say here, is that you have things like your traditional data warehouse, which nowadays the best pro here is that it's a turnkey solution. These are things that you can easily get on any marketplace. They're available to you. They're mature offerings. They're great. Some of the cons are that you're locked in. Your data might not be available to other tools and query engines. They can be expensive because they lock you in. It is what it is. The best part about data lakes is you have open data access. You can build on open object storage of many data formats. And at this point in time, I would say that almost everybody is using data lakes purely. I would say there's very few people who are just using a traditional data warehouse at this point. Most people are on their way to being on Apache Iceberg or being on Delta Lake. They're still evolving. There's lots of confusion about which formats and data catalogs are best. It's kind of there are still people who are using Apache Hootie who are kind of what am I supposed to do now? And again, we don't necessarily be oh, you must go to the newest technology and embrace the new. No, there's plenty of if you're on a solution that works, don't make more work for yourselves. Nobody believes in that. And obviously, there's lots of moving pieces and setup to manage if you're building it yourself. Analytic DBs come with the pros of being speedy and costly. You can do very fast insert and query speeds, but the con is that it's only part of a larger, wider solution. You will almost always need to combine analytical databases with data lakes, other query engines, other visualization engines. It's just one piece of a big puzzle. It's not going to be the only piece. For example, at ClickHouse, there's very few people who would use ClickHouse as their quote-unquote data warehouse only. There are some who do it, but for the most part, we see most people putting their data on Apache Iceberg as their data lake format or Delta Lake, and then they're using ClickHouse, but they're also using Snowflake. They're also using Dremio. They're using all these other tools because that's what they need and require. We don't believe that we're the only tool. We just are a part of the ecosystem of many tools. And this is one of the stories that I wanted to highlight here, which is a story from analytics.com, which is a big data analytics for the Dutch police. And they kind of talk a little bit about how they use ClickHouse as a data warehouse side by side with Postgres. And they also talk about how they used, how they were looking at Snowflake for their solution, and just in general, how they take advantage of ClickHouse being open source in particular, because they work with sensitive police data, they have to run it locally on their own infrastructure. So they're using open source ClickHouse and a small combination, from what I recall, of also cloud. But yeah, this is also one of the benefits of taking advantage of an open source database and open source tooling in general. And this is finally how you can also connect with us. So you're welcome to connect with us on Slack. And this is also a very long blog and article about how we built our own internal data warehouse. So it's not about how we built the agentic LLM one that I just showed you, but it's actually how we built our own internal one and kind of some of the steps and tools and architecture decisions that we made when we did that build. And we also recently, I didn't highlight it here, but I can really quick show it. Give me 1 sec here. ClickHouse Academy, because I should be logged in. I am not logged in. Of course I'm not. Let's see. No, go ahead. Take me somewhere. There we go. Cool. I am logged in. Let's see here. I want to go to the catalog. Yeah, so we recently have, oh, they actually got this open. Okay, cool. So we also have these really nice free ClickHouse Academy courses, like integrating the ClickHouse MCP server with LibreChat. This is kind of like what we did for the LLM agent, and also integrating the ClickHouse MCP server with Claude Desktop. So I didn't really show this because this isn't an AI talk, so it's not necessarily relevant, but basically we have a lot of stuff about how to integrate MCP. And for those who are a little unfuzzy about what that means, it's basically just a way of querying the data out of the database for these AI workloads. That's the gist of it. But yeah, thank you guys so much for coming to my talk. If you have any questions, please feel free to either come up and find me on this right-hand side of the stage, or I'll also go over to the little speakers corner just beyond the stage outside. But yeah, thank you guys so much.